Okay, this is section 7D. So we've seen the double angle rules. We should be able to use those now, as well as the addition formula as well. So let's have a look at some questions and how we can use these to solve equations. So instead of sort of doing something like, I don't know, 2 sine of 3 theta plus 15 equals 4 or something. That's not a good question because that's impossible. Let's make that 1. Instead of doing something like this, we can add quite a few more layers to it now. Okay, so the question is solve 3 cos of 2x minus cos of x plus 2 equals 0. So the first thing you want to spot here is how there's a mismatch. This is about 2x and this is about x. Now you don't want that, okay, because you cannot sort of simplify these or anything. So what you want to do is you want to deal with the 2x over here so that everything is about x, and then hopefully some stuff will simplify and you can work with that a little bit easier. So let's have a look. There's a few ways we could do this. Remember, cos of 2x, which has been done here, has 3 different ways that you could write it. So we could have gone with cos squared x minus sine squared x. We could have gone with what they did here, which is 2 cos squared x minus 1, or we could have done 1 minus 2 sine squared x. So you need to look at this one here to help you make that decision. If you pick the top one, which is quite rare, you have the problem that you have cos and sine, which is not great. That doesn't make things easier. If you pick the second one, which they've done here, notice that it turns into a quadratic. Cos squared, cos, no cos. Okay? It's like, well, at this point here, this is like our 6y squared minus y minus 1 equals 0. It's a bit like this, which you would have seen earlier in the course. So it's nicer to deal with. And if we had done the third one, again, we'd have had that problem. We'd be talking about sine and cos together. So that's why we chose this version here. This has been done inside the brackets, which is the safe way to do it. Okay, so you expand out. Don't forget there and there. We clean all of this up. I would personally do a substitution just to make sure that you can't go wrong. And then you get two sorts of equations in cos, and it gives you 4 solutions. And that might sound familiar, that if you have quadratics with trig, you often end up with 4 solutions. So the important part is really noticing 2x and x means you need to do something with 2x. And then before you sort of jump in, just thinking carefully about whenever you have cos of 2x, yeah, asking yourself, which one is the best one to use. Okay, let's do another one. So solve 4 cos, and this is cos of theta minus 30 equals 8 root 2 sine of theta. So a little bit different here, but there's a mismatch again. They both have theta in the question, but that one has a minus 30 and that one doesn't. Now that means you're not going to be able to use year 12 techniques. Okay, you cannot just sort of do this sine divided by that cos, because they're different things. Sine A over cos A is like fine, that's tan A. But if you have different inputs, it's like sine A over cos B. Yeah, that's not good. That wouldn't give you tan. Okay, so we notice that there's a subtraction here, so we can use one of the addition formulae instead. So 4, I'm going to leave the 4 outside. Now, what's the rule about cos? So hopefully you remember that to save you some time. So it's cos. So cos theta, cos 30. Cos does the opposite sign, so it's plus, and it's sine 30 sine theta. Okay, that's what all of the left-hand side will become. And the right-hand side stays the same. So, I mean, really, I could have just done what would have been a bit easier. I could have sort of done a separate stage before. I could have done cos of A minus B. I might have written that out. Might be a little bit better. Okay. So we do this one here, and it equals 8 root 2 sine theta. Now, there's a lot of cleaning up that needs to be done there on the left-hand side. So cos 30 is root 3 over 2. Sine 30 is a half. Let's sort of do all of that now. So 4 cos theta times root 3 over 2 plus, I'm going to put the half at the front, and I've also got the 4, so, well, there's quite a bit going on here. 4 times a half, let's say 2. So 2 sine theta equals 8 root 2 sine theta. I still need to do a bit more, but can you see now everything is about theta? So this is much better. What we're going to do, we're going to multiply that one. So 2 root 3 cos theta. And I'm going to take away, what shall we do here? Yeah, let's take away the 2 sine theta to the other side, okay? Equals 8 root 2. I'm going to factorize that out, in fact. So it looks like that. Okay, so we're almost there. We're getting much, much closer. If you have cos theta and sine theta and there's nothing else going on, the trick is to use tan. Okay, so divide by cos theta both sides will give you 2 root 3 equals this bracket, tan theta. Move this underneath and solve and so on. Okay, between 0 to 360. So a fair bit going on there, but it's again about noticing that there's a mismatch between these here and using a rule to deal with that. So pause the video and have a go at this one here on the right hand side, which is a similar sort of question. Okay, so hopefully you've done that. The 2, keep the 2 out the front, deal with all of this sort of stuff here in brackets. That's the best way to deal with it. Okay, cos 60 is a half times 2. That's why this part here is just going through. That's why they've simplified a lot. Sine 60 is root 3 over 2 and times by 2, so you get root 3 cos x. And a similar sort of thing there on the right hand side. What have they done next? So they've taken away sine x from both sides. They've taken away root 3 over 2 on both sides. And then from there, they've done the same sort of thing. This one is in radians, though. Okay, so 0 to 180 for that one. In fact, that one there should be invalid, shouldn't it? Because that one lies outside of pi. That would be okay if it were 2 pi, but it's not. Okay, and we're going to do just one more harder question. So a little bit of space for this one. So by noting that 3a is written as 2a plus a, well, okay, 3 is 2 plus 1. You know that, but they must have told you that for a reason. So there's probably something we need to do with that. Show that sine of 3a equals this. Okay, so that 3a, what I'm going to do is I'm going to break it up as was suggested there at the top. So I'm going to write it as 2a plus a. And then I'm going to work with this and hopefully get this right-hand side. So what does the sine addition rule say? It says sine of a plus b equals sine of a cos b plus sine of b cos a. So let's use that. So that would give me my a here. What's in the position of a is actually 2a. And what's in the position of b here is a. So if I did this, I would get sine of 2a cos of a, that's those two done, plus sine of b, so that's sine of the first part. Okay, and then cos, that's sine of the second part, and then cos of the first part. So one way you can test if you've done this properly is you should have sort of like 4 different pieces, which I have. Now, if we look at that and we look at what we need to get, sine A, okay, I can kind of see that happening. The cubed, it's not obvious where that's coming from yet. But what have I got here? I've got lots of stuff about 2. So I've got it there and I've got it there. And there's a rule for that as well. So I've used the addition rule, but now I'm going to use the double angle rule for this and for this. So sine of 2a is going to become 2 sine a cos a. And then there's also that cos a there as well. So that might be why things are appearing as squared. That might be why. Plus sine a. And now this is more difficult. Cos of 2a, you need to think carefully here about which form is best for you to use. So might I suggest, by looking ahead, you can see that it's all about sine. So probably we want to use the one that's about sine. So cos 2a equals 1 minus 2 sine squared a. That's the one that I'm going to use. So if I put that result in, 1 minus 2 sine squared a. I could have sort of done the brackets on that one as well. So let's simplify things and see what happens. 2 sine a cos squared a plus sine a from expanding that bracket there. And then again, that will be minus 2 sine cubed a. So it looks like we're getting much, much closer now. Now they have stuff only in sine, we have cos. Well, we have another way of dealing with that, don't we? Which is sine squared plus cos squared equals 1. So cos squared must be equal to 1 minus sine squared. So we've done the addition rule. We've done the double angle rule for sine and for cos. And now we're even going to use the year 12 identity. So this question sort of has everything going on with it. Okay, so 2 sine a, I'm going to substitute in this part here now. So that will be 1 minus sine squared a, and then all of this stuff again. Cleaning up the left-hand side, we have 2 sine a, and then we have minus 2 sine cubed a plus sine a minus 2 sine cubed a. If you look at the sine cubed, there's a minus 2 and another minus 2. That gives you your minus 4. There's a 2 sine a, and then there's another sine a. That's your 3 sine a. So there's quite a lot going on in that question. It's a little bit of a tricky one, but that's how we would do it. So I'm just going to stop there for a second because we're going to do part B as well, but I'll clear the whiteboard. Okay, so addition rule, double angle for both, and then looking at what you have and what they have. And if you have cos squared, for example, and you think sine is a good thing to have, use this identity to substitute it. Okay, so now that we've proved this result here for part A, let's have a look for part B. So hence or otherwise. Now, whenever you hear this phrase, hence or otherwise, I strongly suggest that you read it as hence, because the otherwise part is usually really, really, really difficult. So hence means we're supposed to look at part A, and it's supposed to give us something useful, something helpful. So they want us to solve 16 sine cubed theta minus 12 sine theta minus 2 root 3 equals 0. Okay, now there must be a reason why that's a part B question. It must have something to do with this part A. So let's write down the part A again above. So part A says sine of 3a equals 3 sine a minus 4 sine cubed a. So I would spend a little bit of time now just sort of looking at these two and trying to see, well, this is the result in part A, so probably something here helping you in this question down here. So it doesn't have to look exactly the same, but some sort of pattern. So hopefully you spotted that if we sort of multiplied this right-hand side by 4, we would have 12 sine, and then we'd have minus 16 cubed, which is quite similar to this part here. Don't worry about the 2 root 3. Okay, the 2 root 3, we can deal with that in a moment. So a few ways we could do this, but I think what I'm going to do is I'm going to multiply this top equation. So I'm going to multiply both sides by -4 and see if you can work out why I'm going to do that. So -4 sine of 3a equals, well, that would be -12 sine a plus 16 sine cubed a. So that part's the same, and that part's the same now as well. And this part, all of this here, we just worked out can be written by this part here on the left-hand side. So all of this, I'm going to write this as -4 sine 3a. Now, there's other ways you could have done that, but I quite like starting with the rule and multiplying up the rule so that it looks the same. I think that's quite a nice way to do it. The -2√3 goes over there. And can you see that from there we're going to be able to solve the question? So if you move the 4 sine to the other side, you get 4 sine of 3a equals -2√3. Divide by 2 on both sides. Divide by 2 again. Sine of 3a equals -√3 over 2, and you're ready to solve, aren't you? Okay. So I'll leave the solving part for you. Don't forget to, when you do your inverse sine now, or your arc sine, don't forget to write all of your values. And remember that that's what 3a equals. For the final part, you must divide each of your answers by 3. Okay. Just like this. So there's a neater version of the working out on the board. A question to practice, pause the video and have a go at this one here. Notice that's a squared sign outside. And yeah, the questions are starting to get quite a lot more difficult. You're probably noticing. So you need to practice quite a bit and ask your teacher if you're struggling. Okay, so that takes you to exercise 7D. I'll just reveal the your turn without all the markings on it. So for the your turn, this is what we're going to get.